Alright, so this is the question that we're looking at. It's similar to the one yesterday, in that we're trying to find the number of terms, okay? Yesterday's was for an arithmetic, this is for a geometric. So we have our sequence, which is summing the integer powers of 2. So the first one is not bad. The first one is, come on, 2 to the 0. 2 to the 0. The next one is 2 to the 1, 2 to the 2, and so on. Okay, so that is where our sequence is coming from. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4. Okay, so the common ratio, what are we timesing these by each time?
2.
Good, so R is equal to, oops, R is equal to 2. So we want to find the least number of terms so that S of n is greater than this amount. Okay, if we want to find the least number of terms, what letter are we trying to find? N. Okay, we're trying to find n. So we're going to use our formula for the sum of the first n terms. So our formula for S of n is equal to, what's the formula, anyone? U1 multiplied by
R squared to the power of n squared. Oh wait, no.
R to the power of n.
Minus
Okay, what's going on? R to the power of n minus 1 over
R minus 1.
R minus 1. And we want this so that it is greater than, yeah, about here. 7, 8, 9. Okay, so we've put in everything we know. Okay, I'm going to do the next line and then I'm going to let you try and figure out from there, okay? So U1 is 1. R is 2. N is what we're trying to figure out, yep. And let me just go up here. I'm still subtracting 1, and R take away 1. What is 2 take away 1? 1. And that is greater than, I'm going to put this as 10 to the power of 10 to the power of 9, okay? I'm going to leave you there to try and figure out what to do next, okay? You're trying to solve for n, remember? Alright, so if we expand this, yep, the ones are just going to go, so I'm just left with 2 power of n minus 1 is greater than 10 to the power of 9. Then what?
And then I took the 2, wait no, I took the 1 to the other side.
Right, good, so it's 2 to the n is greater than 10 to the power of 9, and what do you have to do to that?
Plus.
Yeah, we're adding on 1. Okay, good. Now I could write that whole number out with the 1, that would be fine. At this point, I'm solving for an exponent, so I need to use logs, right, good. Yeah, so at this point, I'm solving for an exponent, so I need to use logs, okay? Solving. All good? So let's see if you can. Alright, so we now are down to here. How do we put this in terms of logs? What's the rule you're going to use? Like log, let's say log to the base b equals c. How do we change that back into exponents?
I'll just do my shooty thing.
Okay, so do it.
Well, you bring A up, so it looks like an exponent, and B up, so it's the main number, and
Yep.
then you switch A and C.
Right, so can you do that for me here? Just doing it the opposite way around.
Sure. Okay, well, what do you mean? Like for
What's
the
your
number?
base? What's the base in that?
For that?
Yeah.
B.
Okay, so b is the base.
Yeah.
This is always the what in the equation? The
It'd be the exponent.
the exponent, because that's
Yeah.
what you're solving for. Okay,
Mhm.
so this is what I'm going to use. Now remember that is in your formula booklet as well, okay? And so going back over here and applying that, somebody tell me what to write down?
Log to the base 2
Sorry. Log to the base 2.
in brackets 10 to the power 9 plus 1 is greater than n.
No, has to be smaller.
I mean, yeah. No, no, no,
Okay,
yeah.
is
Less than.
Less than n.
less than n?
Yeah.
You sure?
Because, no.
Yeah, yeah, it's less than, yeah,
Why is it less than?
because n has to be greater.
Yeah.
Yeah.
N has to be,
Or, sorry, that's 1 billion, and 1 billion has to be smaller than the, because it's the least number of terms.
okay, well let's think about it in this way. If I take logs of both sides, I'm going to have log to the 2 to the power of n. That is greater than log 10 to the 9 plus 1. Yep. What do I do with the n up here?
Put it in the form.
I bring it down. To the 9 plus 1. And then divide both sides by. Divide both sides
I
by.
log to the base 2.
Right.
Wait, why?
Because you myself, you have to get.
Oh, yeah, I
So
know.
it's a mistake there.
I didn't do that.
So this is just another way you can do it, okay?
Oh,
All divided by log 2. So remember, this was one way that we did it in our taking logs both sides, okay? This way is absolutely fine. The problem with this is, can you put this into the calculator?
Yes. I mean, no, which one are you talking about?
This one.
well,
Yes,
yeah, I'll
yes.
send that over
How do you
that.
put it into the calculator?
Log, no, you have to do
Plus
yeah.
over log
over
2.
log.
Right, so you change the base, yeah?
Yep.
You change the base and you basically end up back at this point. Does that make sense?
Yep.
All right, good. Let me scroll down a bit. And then we put all that into our calculator. And come on. I'm getting used. So I end up down here with n is greater than. What number do you get when you put all that in? 29 point.
Yeah, 29.9. Approximately.
29.87.
Yeah.
Okay, and because
No,
8, 9.
9, okay.
Yeah.
Because this has to be a whole number because it's a number of terms, n is equal to 30. Now, if this was 29.4, what would your answer be? It would still be 30, okay? Because it's saying, we're saying here n is greater than 29 point whatever it is. If it was 29.01, you would still round it up to 30 because n is greater than that. It has to be a whole number. Okay, so there's 30 terms. Now, the good thing about this is you can check, you can take your 30, and if you put it back into your formula up here, okay, with 2 to the power of 30 take away 1, you will get a value bigger than 10 billion. Okay, all good? Right, so we're going to have a look at the practice 6 problem solving, page 157. If we go, is this, okay? Marco, if you are at home and feeling up to it, you can have a go. This is what we're going to be looking at today, and then on Monday we're going to be moving on to infinite geometric sequences, okay?
Oh, yeah.
Which sounds horrible, but it's absolutely fine. Okay.